Lesson 2. Welcome to the second class of the Little School of Programming on the Commodore 64 in BASIC. Today we will give some advice and get familiar with some more important commands and possibilities, as well as make examples related to them. To begin, a small introduction. Types of errors that occur in programming. During programming, two types of errors can occur: syntactic and logical. Syntactic errors are those that happen when entering the name of a command incorrectly, which the computer immediately recognizes and signals with the message syntax error and the number of the program line in which it occurred. This error also includes those that occur due to incorrect input of the data type. For example, when we try to enter text into a variable that requires a numerical value. Then we get messages like redo from start and similar. Much more inconvenient are the so-called logical errors. These are errors that occur in programming and are not visible at first glance but produce incorrect program results. Then it is necessary to thoroughly review the program, enter various input data, and follow how they are executed step by step until we finally realize where the error is. Important note: when writing program lines lengths, make sure that for that line you have input in 2 rows. If you have more rows, you will get the message syntax error. The computer has taken only the first 2 rows and considers that the third row starts as a new line, and since there is no number at the beginning, it will try to execute the command as if it were in direct mode, which will result in the mentioned message, and the line will not be entered into memory. In that case, go to the line number you were entering, press return, enter on it, and the first 2 rows of that program line will be accepted. Therefore, if you need to enter a larger number of characters, for example, with the print command, keep in mind to break it into several program lines. A small tip: when typing on the C64, there are 2 sets of characters, the first set of capital letters and symbols, and the second set of small and capital letters. You switch from one set to another by pressing the Commodore key, Control in the emulator, and the Shift key simultaneously. I recommend working in the first set, except in cases where the use of both uppercase and lowercase letters is important to you. On the C64, of course, also in the emulator, if we want to see the contents of the disk, we type load $8. It is important not to add 1 at the end of the command. This command will load the contents of the directory into the computer's memory, which you can list with the list command. Keep in mind that this procedure will erase any previous BASIC program that you had in the computer's memory, so be careful. You can also use the so-called wildcard characters and D. For example, if you want to load the first program in the directory, you will type load 881. For the first program in the directory that begins with the letter B, you will type load B 8.1. For the first program in the directory that has the second letter A in its name, you will type load A 8.1. Let's start with today's lesson, entering multiple commands in one program line. A: allows you to enter multiple commands in one program line. Example, 10 print C64 JE Olitzen print Rakenar. And in the next row, Rakenar pi, mathematical constant pi. The approximate value of this constant is 3.14159 and represents the ratio of the circumference to the diameter of a circle, or the ratio of the areas of a circle and a square on its radius. It is used for calculating the circumference and area of a circle, etc. In the emulator, to get this symbol, you need to press Shift-Delete exponentiation. If we want to multiply a number by itself the desired number of times, this is called exponentiation. For example, we want to raise the number 2 to the power of 3, which is the same as 222, and gives the result 8. In the emulator, the exponent symbol is obtained by pressing Delete End of program. If we want to stop the execution of a program in a certain program line, we enter the command end in it. Rem, entering comments. This command allows the user to enter comments for each program line, which makes it much easier for those who review the program. A major drawback of this command is that, depending on the size of the comment, it uses up quite a bit of computer memory, as well as increases the amount of data written to cassette or disk. Therefore, in large programs that require a lot of memory, it should be avoided. Command format is rem comment. Example, 10. C64 rem. This will print the text C64 on the screen. Screen, printing and cursor. Commands for clearing the screen, moving the print and cursor Freileis. On C64 computers, the designers invented a unique way to manipulate the screen and cursor through programs. Namely, when we want to send the cursor to the beginning of the screen in direct mode, we would press the CLR home key. In the emulator, that is the home key. If we wanted to clear the screen, we would press the combination Shift CLR home. Moving the cursor, and thus the place of printing, would be done with the arrow keys. How to transfer that into a program. The designers of the computer solved this by making it so that when the programmer opens quotation marks, instead of executing the mentioned actions, the symbols are printed in reverse video, and when the quotation marks are closed, normal execution resumes. It all looks like this. CLR home, moving the cursor to the beginning of the screen, inverse letter S, Shift CLR home, clearing the screen, inverse heart symbol. Cursor left, inverse dash in the middle, cursor right, inverse right middle block, cursor up, inverse circle, cursor down, inverse letter Q. Keep in mind that on the C64// emulator, these symbols appear as single characters. To start these actions, the print command is used. They can be started both in program and in direct mode. Let, assigning values to variables. The formats of this command are: let a equals 10 assigns the numerical variable a the value 10. Let n equals C64 assigns the text variable $n the value C64. We must admit that this command has little purpose on the C64. The reason is that the computer assumes the let command, so it is enough to write a equals 10 and n equals C64, and that is how we will do it from now on. CLR, clearing the contents of all variables. This command gives all numerical variables the value 0 and clears the contents of all text variables. Input, entering data into numerical and text variables from the program. We have seen how to assign values to variables in direct mode and in programs, but of course it is most important to allow the user to enter values into them while the program is running so that they can be processed and give the desired result. That is where the input command comes into play. This command allows data entry from the keyboard. The command itself can display text on the screen like the print command. Command format is input A, enter a numerical value, input A, enter a text value, or input enter number, A input enter text, $. If we incorrectly enter a text value into a numerical variable, we will get the message redo from start, and the program will ask for the input again. If we enter a numerical value into a text variable, nothing will happen because the computer considers that we entered text. We give small examples. 10, input, what is your name? Name $. 20, print, hello, name $. The computer will ask for the user's name and then print on the screen, hello, user's name. "10 input, enter the radius of the circle. R20, print the circumference of the circle is. 2r pi 30, print the area of the circle is. R less 2 pi. The computer will ask for the value of the circle's radius and then calculate the circumference and area of the circle based on it. For to step next, program loop. These commands always go together, except the step command, which is optional, and execute a series of commands located between them a given number of times for a certain step, optional. Loops are often used in programming and have many different applications. The formats of the commands are for some numerical variable from the given initial value, to go to its given final value. Step, for some given step, either positive or negative, integer or decimal. If omitted, it is assumed to be +1. Next, increases the value of the variable and returns to the first command after for to step if the value of the variable is not greater than the given final value. In that case, it moves to the next command. Also keep in mind that in the next command, the name of the variable does not have to be entered because the computer assumes it, but I warmly recommend that you do so at least in the beginning, because from my personal experience, unpleasant, confusing situations can occur, especially in complex programs with many program lines. The following simple example will illustrate this. 10 for I equals 1 to 9, step 2, 20, print I 30, next I. In the first program line 10, the program counter is given 1 as the initial value of the variable I, which will increase by 2 in each cycle until the final value 9. In program line 20, the value of this variable is displayed. Line 30 increases this value by 2 and returns the program flow to the first command after for to step, in this case print in program line 20, unless the variable I has a greater value than the final given value, in this case 9. When the last pass is 9, increasing it by 2 will give the result 11, which is greater than the final given value, and therefore it moves to the next command. And if there are no other commands and program lines, the program ends. In this way, we have displayed all odd numbers from 1 to 9. If, then, executing commands if the condition is met. The commands if and then are important commands that execute program commands depending on whether the condition is met. If a condition is met, then do this. The conditions can be equal, less than, greater than, equals less or equal, equals greater or equal, not equal, as well as the logical operators not, and, or. We will best illustrate this command with the following program. Let's explain what happens here. In program line 10, we clear the screen. Line 20 clears all the values of variables that we will use in the program. Lines 30 to 50 print instructions for the players. Line 60, the first player who thinks of the city name to be guessed enters that name, and the computer stores it in the text variable city dollars. Line 70 clears the screen again. Line 80 starts a loop that will execute 10 times as well as all commands between the for and next commands. Line 90, the second player who is guessing enters the name of the city they think is being asked for, and the program stores it in the text variable guess dollars. Line 100 compares the two text variables city dollars, which contains the name of the city being guessed, and guess dollars, which contains the name of the city the second player thinks it is. If the condition is true equals and the two text variables are identical, then bravo, you guessed it in is printed. The numerical value of the attempt contained in variable I is added in the printout, tries, and the program ends. If the condition is not met, it goes to line 110. You did not guess is printed. The next command increases the variable I by 1 and returns to line 90. The command that comes after for2, where the second player is again asked to guess the city. If it reaches 10 times and the city is not guessed, next no longer returns the program flow. It moves to the next command found in line 120, and the game ends. That's all for today. We will finish the second lesson with the message, be creative. Try to make your own program with the commands we learned today. It doesn't matter if you don't manage to get the desired result the first or several times. What matters is that you don't give up.